Hi, I'm Andrew Frankenfield, agronomy educator with Penn State Extension. Grain drills are important tools for the establishment of grain and forage crops, as well as cover crops, and they are a cost-effective way to establish close-seeded crops. This video provides easy steps to calibrate your drill. Seed charts provided by the drill manufacturers give a good starting point for obtaining the desired seeding rate, but they may not be very accurate. Variables that can affect seeding rates include differences in seed size and shape among crop varieties, seed coatings or seed treatments, and seed density. From time to time, new species or mixtures of two or more species that are not listed on the drill seeding chart will be planted. Let's begin drill calibration. First, determine the seeding area when driving the calibration distance. Calibrate the drill for a driving distance of 200 feet. This is an arbitrary length, but is long enough to capture the field variability, yet not too long to be impractical. Next, determine the width seeded by your drill. In this example, we will be using a drill with a working width of 10 feet. Working width is calculated by multiplying the spacing between seed openers by the number of openers on the drill. The area seeded in our example will be 2,000 square feet, which is 200 feet long by 10 feet wide. To calculate the fraction of an acre, divide 2,000 square feet by 43,560 square feet per acre to arrive at an area of 0.046 acres. Now, count the number of grain drive wheel revolutions when traveling the calibration distance. In the field, use a measuring wheel or tape to measure the course that is 200 feet in length. Determine which wheel is responsible for driving the seeding mechanism on the drill. Our goal is to figure out how many revolutions this wheel will make in the field in a 200-foot length. Apply a piece of heavy tape to the wheel to enable you to easily count the wheel revolutions while driving. Drive 200 feet, which you previously marked out in the field, and count the number of revolutions made during the distance. For increased accuracy, repeat a few times and use the average. Now we will need to set up the drill for calibration. Stationary calibration is accomplished by simulating drill operation. The seed delivery system of the drill is operated much in the same way as it is when being pulled across the field by turning the drive wheel the number of turns determined in step 2. Stationary calibration is done by lifting the drive wheel above the soil surface so it can spin freely. Some type of hydraulic shop jack is often used to accomplish this. Keep the drill securely attached to the tractor to maintain a level of safety when elevating the drive wheel and to operate the hydraulics on the drill. It is often necessary to lower the drill, permitting the drive mechanism to become engaged so the seeding rate calibration can be accomplished. Using the rate chart supplied by the drill manufacturer, often found on the underside of the seed box lid, adjust the seed meter for the desired seeding rate of the species of interest. If your seed is not included on the chart, estimate a seeding rate by selecting a similar sized seed. This will give you a first approximation. Ensure that enough seed has been added so that the seed cups are full and the seed metering fluted wheels or sponges are completely covered and will remain covered as the seed is metered out during the calibration process. Turn the drive wheel to prime the meters, usually a few turns is enough, then determine which method of seed collection you will do. Seed can be collected by one of two methods. The first involves the use of a large tarp that can be placed under all drill openers so that the seed falling through the seed delivery tubes and disc openers can be collected from below using the seed delivery mechanism and weight. The alternative method involves removing the seed tubes from the disc openers assembly and placing them into several buckets or containers used to catch and transfer all the seed to one container for weighing. At this time, the drive wheel can be turned in the correct direction until seed begins to fall from all openers. If some openers do not drop seed, ensure the seed tubes are not kinked or obstructed by things like straw or spider webs. Now you are set to start collecting seeds for calibration. Ensure that the drive wheel has been turned to a convenient starting point. A mark on the drive wheel or chalk, marker, or tape is suggested, and that the tarp or buckets are clean. The best way to collect seed from all openers due to the small area that is represented for this calibration. Then, to calibrate the drill, turn the drive wheel the number of revolutions needed to represent 200 feet of travel as determined earlier. Collect all the seed from the tarp or buckets and weigh the total. Keep in mind that calibration is a trial and error process. The seed is collected from the simulated seeding of a fraction of an acre, weighed and compared to the desired seeding rate. If the rate is too low, the metering mechanism is adjusted to deliver more seed and the process is repeated. It is desirable to maintain a record of the seeding rates for each setting as one works towards the desired seeding rate or rates. Determining the seeding rate of the drill in this example is completed by dividing the total seed weight of the area drilled, which is 0.046 acres. For example, 2.3 pounds collected represents a seeding rate of 50 pounds per acre. Seed mixes are becoming more popular with the increased understanding of the complementary of the different species grown for forage or as a cover crop. Calibrating the drill for mixtures is no different than calibrating the drill for a single species. As a first approximation, determine the seeding rate of each species in the mixture and divide the normal setting rate of each of these species by the number of species mixed. So, if for example you mix hairy vetch and rye, and a normal seeding rate is 20 pounds per acre for hairy vetch and 2 bushels per acre for rye, you may plant 10 pounds per acre of hairy vetch and 1 bushel of rye. To compose the mixture, determine how many acres to plant, weigh the amount of seed of each species, and mix thoroughly. If a two-species mixture is planted and each species can be seeded through a different box, you can calibrate each box for that species individually. If the seeds are mixed prior to calibration, calibrate using the guidelines for the single species. Finding the first setting may be the most challenging. In many cases, mixtures will pack more densely, so start with the setting for the seed species of the largest seed and then adjust accordingly. In the above example, you might want to start with a setting for 1 bushel of rye. After calibrating the drill, you can keep track of your seeding rate after drilling a few acres. True seeding rate can be determined by one of several methods. Most modern grain drills are equipped with an acre meter. Use it to monitor the seeding rate. Keep track of the seed you have used and divide the amount of seed drilled by the acres planted. Alternatively, if an acre meter is not available on the drill and the acreage is known for the given field, calculate the rate in a similar fashion. If minor adjustment is needed, use the seeding rate increments between settings to more accurately make the adjustment. Actual seeding rates may vary somewhat due to ground cover, soil conditions, overlapping between passes, and driving speed. This information is also available in a fact sheet titled Calibration of Grain Drills or Agronomy Facts 75. If you have additional questions, feel free to contact me at the information on the screen. Thank you.